Hi there, it's Mrs. Tellas. We're going to do a video for section 7.1, classifying and adding and subtracting polynomials. So here we go. All right, you're going to want to press pause and copy this definition. A monomial is a number, a variable, or the product of numbers and variables. You're not going to see an addition or subtraction sign holding things together, but you might see negative numbers. So here are some examples of what monomials look like. So there's no other term connected. It's just one term. And in fact, mono means one. Okay? All right, the degree of a monomial. Press pause and write the definition down. It's the sum of the exponents just of the variables. Just of the variables. So if I look at this, I accidentally clicked it so you can see all the answers, but this is degree 1. Okay, because the exponent has a degree of 1. This is degree 5 because 2 plus 3 is 5. So the first one is 1, the second one is 5. The third one doesn't have any variables, so the degree is 0. And the fourth one would have a variable here and here, both exponents 1, so the degree is 2. So all I'm doing is looking at the variables, and if there's more than one, I add up those exponents. Okay, again, press pause and copy this definition. A polynomial is a monomial or the sum or difference of monomials. So here's a nice big polynomial. Okay, special cases for polynomials. A binomial is 2 terms, and a trinomial is 3 terms. So for example, a binomial might be x squared minus 16. 1, 2 terms. Okay, or a trinomial might be x squared plus 10x minus 15. Okay, there's 3 terms here. Okay, we'll be doing a lot with trinomials in this particular chapter. Okay, and then standard form is when the degrees of the monomial terms decrease from left to right. So I wrote this one up here in standard form. The exponents go 2, and then 1, and then 0, because there's no x here. Or 2 and then 0. So it starts with your highest exponent and goes down in descending order. Okay, so here are some examples of standard form in terms of x. So x squared, x to the first, and no x. X cubed, x to the second, x to the first, and no x. And then if it's in terms of x, I'm just looking at the x term on this weird one. So x to the fourth, x to the third, x to the second, x to the first, no x. Okay, so I wasn't looking at the y because it says in terms of x. So start with the biggest exponent, number, and then work your way backwards. All right, a degree of a polynomial is the same as the degree of a monomial with the largest exponent. So you're going to do a degree of monomial for each of these, and then you will go with the biggest number. So the degree of monomial for this one is 3. The degree of monomial for this one is 1. The degree is 0. So the degree of this polynomial is 3. 3 is my answer because it's the winner. And here I've got a degree 2 and degree 0. So the winner here is degree 2. Okay, so you do the monomial for each term, degree of monomial, and then you go with the biggest number. Okay, so adding polynomials. So when we add polynomials, we add like terms, and the exponent stays the same. So really all we're adding are the coefficients or the numbers in front of the variables. So they have to be exactly the same letter with the same exponent to add them. So 3 plus 5 is 8, and a to the second stay the same. This is the answer. Now you can also present this vertically. They're on top of each other because they have the exact same letter with exponent. So this is 8, a to the second. See how I get the same answer? Okay, the book shows these horizontally, and I look at them horizontally. So in order to add them, they must have the exact same variables with the exact same exponents. So as I look at this, I see this is xy to the second and xy to the second. So since it's exactly the same, I can go ahead and combine the front terms. So 14 minus 8 is 6. So 6x to the second. Notice that I kept the x, y to the second exactly the same. Didn't change it. And we can add in grouping symbols, but we still do the same thing. We go and gather the like terms. So where these two are like, remember there's a 1 here. So I'm adding 1 and 4 is 5n to the third. And then here I'm adding positive 5 and negative 6. Those are constants because they don't have a variable. So that's negative 1. Why don't you press pause and try 4 and 5 and see if you can come up with it? Remember, you're adding the coefficients on ones that are alike. All right, so hopefully you press pause and gave these a try. Notice you've got x squareds, you've got x's, and then you've got constants that we're going to be adding or subtracting together depending on their signs. So 6 and 2 is 8x to the second. Negative 2x and positive 7x is positive 5x. And positive 5 and positive 4 is positive 9. So this is my answer. Okay, and it's in standard form again because my highest exponent is first, my second highest, and then no exponent on the x is last. All right, and then here, this one, hopefully you did this one too. So 8a to the third doesn't have another one to get together, but it's got the highest exponent, so it goes first. And then I've got some squareds. Oops, I think I want to do those in a different color. Then I've got some squared a squared terms that I can put together. So that's negative 5a squared. And I also have some, or just one positive or a term. So plus 6a. And then minus 10 is completely on its own. Oh, nope, there's another a term. I messed that up. Let's fix it. So here's a 4a. I just didn't see it. So that a term is going to be different. My bad. So that won't be 6a. That'll be plus 10a. There we go. And again, in standard form, the highest exponent, the next one, and the next one, and no way, that constant is last. Okay? Hopefully you got those right. Okay, when we subtract polynomials, and you can see they look exactly like the adding ones. I mean, there's usually grouping symbols with a plus sign between for adding, and here there are grouping symbols with a minus sign between. So here are the steps. So if you want to write those down, press pause and write them down. So that negative sign in the middle needs to be distributed to the second parenthesis. So you're going to change the signs and all the terms on the second parenthesis. And then you'll add like terms just like we did on the previous screen. So we've got this term minus this term. So that would be negative 3x squared. That would be positive 2x. And that would be negative 12. And all I did was change their original signs. And now I'm just adding like terms like I did before. So the x squares, that would be negative 2x squared. The greens would be positive 7x, and the blues would be negative 20. It's in standard form, so this is my answer. Okay, you can also do this vertically. The book shows it both ways. So notice how the top grouping symbol, or what should be in a grouping symbol, is just listed, and then we're minusing the other one. So we're going to change the symbol on this one and this one, and it makes it look like that. Now we're just adding vertically. So that's 10x and that's negative 7. And again, it's in standard form because the x comes before the constant. All right, let me do this first one and then I'm going to have you try a few. So I notice that it's a minus, which means I have to distribute the negative into the second parenthesis. So that's going to be negative 2x squared plus n minus 1 in my second parenthesis. And I'm just combining them with these. Okay, so these two, the n squareds are going to go together, and the n's are going to go together, and the constants are going to go together in that order because it has to be in standard form. So that'll be positive 1n to the second minus 5n minus 5. That's my answer. All right, I want you to press pause and try number 2 and 3 and see if you come up with those. All right, so since it's a minus in the middle, I'm going to distribute that minus to the second parenthesis. And then I'm going to combine like terms with that first grouping symbol. So we've got an x to the third in both, and we have a y in both. So that x to the second doesn't have anybody to combine with, but it'll just be second in the equation or in the expression. So that would be negative 1 y to the third, and then minus 2y to the second. And then if I add those together, that's negative 1y. So this is my answer, and it's in standard form. Okay, I hope you tried this other one. So again, we're just changing the symbols here. So negative 4x squared y minus 2x squared xy squared and plus 3xy. Okay, and this one is staying exactly the same. So I'm just looking for the others that are matching x squared y. So those two match because they have the same variables and the same exponents that match. And then let's see, we got an xy here and an xy here. And this one in the middle doesn't have somebody to get with up here. So we're just going to list it. Okay, so we're going to let's put this x squared y first because that's in terms of x. So that would be this one and this one. So that's a negative 3x squared y. And then we'll go ahead and combine. Actually, I think I'll list this one second since it's got a squared in it. And then this one last, so negative 3xy. This is my answer. And the standard form is funny on that one because the exponent for x is 1 and the exponent for x is 1. So on that one, those last two could be situated differently. But that first one should be first because we usually do this in terms of x. Okay, so you're going to big ideas to give these a try. The first ones where you're showing the degree of the monomial, the degree of the polynomial, those don't need work. But when you get to the adding and subtracting ones, those need to have work shown. So if you haven't shown work, please just go ahead and show work on the addition and subtraction. Please number them, take a picture, and submit that on Canvas. Thanks.